Hi everyone, welcome to the OneCodeCamp channel. So in this video, we will dive into the world of Node.js Native Modules. So we will cover the creation of simple modules and then delve into the file system module. So this module allows for various file operations like reading, writing, managing directories, and save deletions. So this video aims to empower both beginners and experienced developers to harness the power of Node.js native features for effective file manipulation and organization. So let's get started.
Welcome back developers and welcome back to OneCodeCamp channel. Once again, this is Ron and today we're going to talk about the native modules and one of its operations, the file system. I hate to keep you waiting, so let's get started. Native modules comes pre-installed with Node.js, offering a treasure trove of functionalities that simplify common tasks and boost productivity. Let's dive in and discover how to make the most of these built-in modules to create robust and efficient Node.js applications. But before we dive in, let's ensure you have a Node.js installed on your system. To check if you have a Node.js on your computer, you can open your command prompt. In your command prompt, you can type node space followed by -b. Hit enter and you will see the Node version installed in your system. If you haven't already, check out our previous video on how to install Node.js on your operating system. Once you have a Node.js up and running, we're all set to begin. In this segment, we'll gain a deeper understanding of Node.js modules and their significance in Node.js development. Specifically, we're going to talk about the native modules. But first, let us talk about what a module is. A module is a self-contained piece of code that encapsulates functionalities and data, making it reusable and modular in design. Modules serve as a building block that helps organize and structure your Node.js applications, promoting better code maintainability and reusability. With the help of modules, you can break down your application into smaller, manageable parts, each responsible for specific tasks or features. This modular approach makes it easier to understand and maintain the codebase, as you can focus on developing individual modules independently. To use a module in your Node.js application, you need to define the module's functionalities and export them so that other parts of the application can access and utilize them. The module that exports object is used to make functionalities available for other parts of your codebase. Furthermore, Node.js provides a powerful mechanism to import functionalities from the module to another using the require function. This function allows you to import and access functionalities exposed by other modules, enabling you to use them in different parts of your application as needed. To further understand this, let's try this concept using an actual coding sample. Let's proceed to our desktop and create a folder named Node.js Modules. After that, let's open a code text editor. You can use any text editor of your choice, but as for mine, I'm going to use VS Code. Using the VS Code, let's open the folder that we just created. And inside this folder, let's create two JavaScript files. First, let's create a file named module.js. After that, let's create a JavaScript file and let's name it app.js. This module will serve as a self-contained package of functionality that we can import and use in other parts of our application. To start with, let's create a function. And let's name our function greet. Let me just expand this a little. Inside this function, let's return a string, or in this case, a greeting. Let's also pass a parameter name so that this function will be able to accept names. And let's complete our string by typing hello and the name of our parameter. Now let's export this function so that we can use it in other parts of our application. To do that, let's type module.exports. followed by an equal sign and the name of the function that we would like to export. And we're done with our module. Just to wrap up what we did. First, we define a function that generates a greeting. After that, we export the function that we just created using the module that exports. Now that we have our module defined, let's create an application script that imports and utilizes the functionality from the file module.js module. Let's open the app.js file. First, let's import our greeting function from the module using the require function. Inside our require function, let's type /module inside a string to indicate the location of our file. Now that we're done importing our module, let us now use this imported function. Inside this function, let's pass an argument named Jan. And finally, let's log this message in the console. Now to wrap things up, what we did is we import the greet function from the module.js module. After that, we utilizes or use our imported function. Now that our application and module is complete, let's try to run this using the terminal. To run this, let's type node space app.js. And that's it. We've successfully invoked the greet function, passed the argument Jan, and printed the result to the console. By creating and using a simple module, we've demonstrated the power of modularization in Node.js. Now that we have a clear understanding of how Node modules work, let us now move on to the native modules. Native modules form the backbone of Node.js, offering ready-to-use functionalities right off the box. These powerful modules empower you to handle common tasks efficiently, saving valuable time and effort. Unlike external modules from the Node Package Manager or NPM, native modules are already installed with Node.js, making them instantly accessible. In this video, we're going to talk about one of the most commonly used native modules in Node.js, the file system module. In Node.js, the fs module stands for the file system module. It's a built-in module that provides methods for working with a file system on your computer. This module enables you to interact with the files, directories, and perform various file-related operations. Now let's switch back to our code editor and perform these operations in practice. The first operation that we're going to perform is the fs.readFile. First, let's create a new JavaScript file, and let's name it fs.js. After that, let's create a text file. For this one, let's name it readme.txt. Let us just write a simple content for this text. I will just write this is the content of the text file. Once you're done typing the content of your text file, let's move back to the JavaScript file. Let's start by importing the fs module into the script. Let us create a constant variable named fs, followed by an equal sign and the required keyword. Since require is a method, let's add an open and closing parenthesis. And inside this, let's import the fs module. Now that we have imported the fs module, we can now access and use its functions for file system operations within our script. Our next step is to specify the path that we want to read. Let's store it in a constant variable and name it file path. To specify the location of our file, let's type // followed by the name of our file. After that, let us use the readFile method to read the content of our file. To do that, let us type fs, followed by that and the keyword readFile. Since this is a method, let's type open and closing parenthesis. Inside this method, we will pass the location of our file. This method will be asynchronous in nature, so inside this method, let's throw an arrow function. This callback function will allow us to handle any potential errors and retrieve the data from the file. To further process this data, let us add a conditional statement. First, let us check if there will be an error. If there will be an error, we will log it to the console. On the other hand, if there's no error, let's console the data. To make this data human readable, let's use the toString method. Alright, now that we're all set, let's open our terminal and test our script. First, let's type node followed by the name of our file. And there you have it, we have successfully read the content of our text file. The next operation that we're going to perform is to write a file using the file system module. Now for easy reference, let us rename this file. And let's create a new file. Let's name the new file fs.writeFile. Again, let's import the fs or file system module. Let's create a constant variable. And let's use the require method to import the fs module. After that, let us specify the content that we would like to write. To do that, let's declare a constant variable. And let's assign a value to it, which will be the content of our file. Let us just type, this is the content that will be written to the file. Next is, we're going to specify the path or the location of our file. To do this, let's declare a constant variable. This time, let's name it file path. And let's assign a value to it, and that value is the location of our file to be written. I'll just use that / indicating that the file will be written in the same folder as this script, followed by the name of our file, or output.text. To create this file, let us use the writeFile method. Let us type fs dot followed by writefile. Inside this, let us pass the file path variable. After that, let's throw a callback function. Inside this function, let us also pass the content to write variable. And inside the callback function, let us catch the errors, if there is any. Finally, inside the callback function, let's create a conditional statement. If there will be an error, we will log the error to the terminal. Otherwise, let us log to the console that we have successfully written the content of the file. And finally, the last thing that we're going to do is create this output.txt file. Now that we're all set and ready, let us now run this script. It looks like we have an error. Let me just take a look at it. I think I found it. It looks like that I forgot to give it a JavaScript file extension. Now this should work just fine. Let's try to run it again. And there it is, we have successfully written a content for this file. Now what if this file is not existing? Let's try to delete this and run this code again. Upon running, this script also created this file for us. Let us now proceed to our next operation, the make directory. For this one, let's create a new file and let's name it fs.mkdir.js. Again, let's import the file system module. To create a new directory using this module, let us first specify the directory path. Once again, let us store the directory path inside the variable. Now let's create the directory using the keyword mkdir. First, let's type fs, followed by that, and the keyword mkdir. Inside this method, let us pass the directory path and a callback function. Once again, let us catch any potential errors. And add a conditional statement. Again, if there will be any error, let's flag it to the console. Otherwise, let's flag a successful message to the console. Let us now run and try this code in the terminal. And there you have it. We have successfully created a directory. Now let's try deleting a file using the file system operation unlink. For this operation, let's create another JavaScript file. Let's name it fs.readFile. And of course, let's give it a JavaScript file extension name. As usual, our first step is to import the file system module. Our next step is to specify the file path of the file that we would like to delete. And let's save it inside the constant variable. Now to do that, let's declare a constant variable. And let's assign a value to it. The value will be the path of the file that we would like to delete. For this, let's create a text file that's gonna be deleted. Let's name it deleteme.txt. Now let's type the path of this text. Let's start by // followed by the name of the text. Finally, let's delete the file using the unlink method. Let's start by typing fs, followed by that, and the unlink keyword. Inside this method, let us pass the variable file path and a callback function. Again, let us catch any potential errors. And let's create a conditional statement. In case of error, let's log the error to the console. Otherwise, if there are no errors, let's log to the console that the file has been successfully deleted. Finally, we're all set. Let us now try and run this code using the terminal. And there you have it, we have successfully deleted the file using the unlink method from the file system native module. Thank you for joining us today. Once again, this is Ron Gilbert, and see you again in the next videos.